Hi, I'm Benjamin Miss. Welcome to Introduction to Psychology, Research, and Ethics. And we'll start by going over a brief review from our intro and look at some of the people that are important to know, some of the key figures. This psychologist founded neuroscience and won the Nobel Prize for his early study of neurons. Is it Skinner, Wundt, Ramon Cajal, or James? And the answer is Ramon Cajal. Same options. This psychologist was a behaviorist. And the answer is Skinner. And which psychologist compared mental elements to physical elements? Ebbinghaus, Wundt, Watson, or James? And the answer is Wundt. Right? Remember, Wilhelm Wundt was inspired by chemistry and tried to say that our thoughts were of the same kind of elements. The molecules of thoughts were of elements, which again, not a bad idea, interesting, but very, very difficult to assess. Ebbinghaus was the guy who did memory. Remember, we talked about, he told us 100 and almost 50 years ago, don't cram, spread out your studying, you may not learn everything right away, but each time you do it, you'll do better. James was the American psychologist, the father of American psychology, extremely influential. Watson and Skinner were both behaviorists. So when we talk about research and ethics, here's what we want to focus on. How do we conduct psychological research? How do we know what we know? Describe the difference between science and pseudoscience. Now, when we talked about myths, we talked a little bit about what is, why do people believe some of these things that are so odd? And we'll talk about why people are led to these beliefs. How do we kind of get there? And then we'll look at some famous psychological studies and look at some of the ethical issues involved and understand how can we really do better in a way. So we look at science versus non-science, right? The scientific method. The idea of a theory and a hypothesis. So these are important things to consider, right? These are also things we want to do. So let's kind of go through what these are. So psychology really started out as an attempt to explain mind and behavior, right? Psychology allows us to test these things. Philosophy of mind, are we good or bad, right? Pro-social or antisocial, nature or nurture in the influence of behavior. And this is what makes psychology of a science, right? Psychological measures, psychometrics, the validity of different therapeutic techniques by seeing what works, testing and looking at the results. Psychology will heavily use statistics, heavily still involved in that kind of analysis because you're looking at large groups, large samples in most cases. So we take, for instance, the mind and we say, all right, we're going to now say, how can we study it? This is one way of looking at the scientific method. There's a lot of ways to describe the steps involved, but we start by observing something about the world and then saying, now that we've observed this, what do we think would happen, right? Remember pragmatism. Remember, that the philosophers would often, even the empiricists would say, well, we know this from sense experience, but even our senses can lead us astray. So how do we test things to make sure that we know what is true? Well, you would then design a study, collect data, analyze, and then that would go back to feeding your observations. The data you collect adds to your observations. So really it's observed, predict, study, observe, predict, study, and you keep increasing your observations. Science works by that, by saying, here's what we know. Are we done? Absolutely not. We keep looking, we keep studying to see how we can do better. Now, you may have heard these words many times. Theory and hypothesis. I would like you to take a moment and write down these definitions. What is a theory and what is a hypothesis? And I'm going to, assume that you've taken time to do this and you've written down these answers and paused the video, and now we're ready to go on. So, what do you think this is? In one word, a theory is an explanation. What do people usually say? People often say a theory is a hypothesis that's been proven. It may say it's something that's true, but in reality, a theory is an explanation. And so here's how it works. You can make a theory about anything. Anybody can make a theory. Anybody can explain something. For instance, you can say that food is digested by these little green men that live in your stomach and help to chop it up when you eat it. And I say, well, why can't, okay, so if I take an x-ray, I don't see them. Or if you have stomach surgery, you don't see them. And the person says, well, they're able to disappear when you look for them. Well, your theory that there's little green men inside my stomach to help me digest food is fine, but there's no scientific validity for it because there's nothing to measure, right? Your theory involves the fact that it's actually not measurable. And there's a lot of things in the world where we have beliefs that are not measurable. Faith, we can measure whether or not you have faith and how strong your faith is, but faith is literally about something that's not measurable. So when we're talking about this, that's what I mean by, anybody can have a theory, but a scientific theory has to be able to be something that involves sense experience that we can really observe. And it leads to hypotheses. In one word, a hypothesis is a prediction, which means based on what we know, what do you think will happen? Here's our theory observed in the world, right? Based on what we know about this, what do you think will happen? If I say stomach acid is important in digestion, and we say, okay, well, if we were to remove your stomach acid, it should cause problems for digestion. Now this is testable, right? We can say with the study that I talked about in the myths video, we can say, well, yes, we believe that acting out your violent impulses will help you to be less angry. Sure, let's study it, right? Let's create a study where we have you act out violent impulses, and then we measure how violent you are afterwards, and we actually see that it didn't help; it actually made it worse, right? So we take our beliefs and we say, can we design a test for them, right? Can we design a way to observe this in the natural world? We believe this, and because we believe this, because we have this theory, it makes predictions about the world. A good theory will be supported by new data. A bad theory might be debunked, and a great scientific study allows you to take multiple theories and create a design that will find support for one and less support for another. For instance, you observe that your best friend is crying. Well, think about this. Think about your best friend crying. Why are they crying? I bet that you immediately have a couple of explanations, right? Because you know your friend, and you know, is their family, do they have a sick family member, right? Are they having relationship troubles? Have they gone through a breakup? Is their pet sick? So you know about this person. And so you can make a guess as to the cause of this. That's a theory, right? That's a theory. And then you would collect data. You might ask them. That's an easy way to collect data. Well, there's a great scene in a video called, a show called The Big Bang Theory, where they do this. They have a character who is trying to figure out what's wrong with her. Because if you've seen the show, you know that these characters are like very, they kind of play up the nerdy tropes. And so this character is in a bar and she sees this guy and she has these weird symptoms that she doesn't understand, right? And the symptoms are elevated heart rate, moist palms, dry mouth, localized vascular throbbing, drinking, and the environment also. She's drinking carbonated water at the time, and when the person's there, she says, "Who?" This kind of like excited sound. And they sit there and they try to come up with, what could this possibly be? Could this be? And they come up with all these like really low probability things, and they throw in at the end, well, maybe it's sexual arousal. Well, right? And then watching it, you're watching it, and you're like, of course that's what it is, right? She's attracted to this person. But when you look at the characters try to figure this out, to them, that's a low probability event. That hosting an alien parasite is they see as more likely than something like that, right? So what this is it might look like a medical test, right? This might look like a diagnosis. Well, a diagnosis is a theory, right? A physician, if you've seen any of those, doctor shows, and they're putting up on the board, here's all the symptoms, what do we think it is? And they list all the possible diagnoses. And then, what are their hypotheses? Well, their hypotheses are, if I go run this test, right, this is what's going to happen. I think it's this, and I think if we run this test, it'll show support for this diagnosis. And if it doesn't, then that's more data, and we refine our theories. So diagnoses are just that. They're theories. And you can either support or, come up with evidence against these things. And so we're looking for ways to support this. Now, normally, I would look, if we were live, for a way to kind of do some pseudoscience, right? And say, let's get a volunteer and let's look at what's actually happening here. And so here's our, for instance, examples of pseudoscience. Well, pseudoscience uses some methods of science to draw predetermined conclusions. So you confirm evidence, right, which is paying attention only to things that support your beliefs. You've heard of snake oil, perhaps, right? Snake oil was, you think of this like traditional thing, was on this bottle, it said snake oil, and here it says instantaneous cure for all afflictions, right? So the snake oil salesman would ride into town with his wagon, and he would sell people these bottles of what he called snake oil. So there was this supposedly derived from snakes and other things. It was this concoction that would make you feel better. Now, a lot of the times, historically, these areas were dry, which meant there wasn't alcohol. And snake oil was, well, mostly alcohol. And so what happened was you would, ride into town with this concoction to make you feel better. You'd be like, oh, you've got arthritis? What you're going to do is you're going to take a little drink of this and you're going to rub some on your hands. Well, you're going to feel good, right? You're going to feel better. You're going to feel a little relaxed. It's not going to hurt as much, right? Maybe there would be some paregoric, some opiates in there, something to relieve your pain. It wasn't a cure, but it was something that would temporarily appear. Add into that, heck, it could have been water with some herbs in it, and use the placebo method. Because if you believe something works, it's often going to. So some people will feel better. So an unscrupulous salesperson could come into town, sell a bunch of this, and especially if they were using alcohol in it, right? And people are enjoying and feeling good, and then they get out of town before people realize what went on. But there's no test of this. There's no scientific trial saying, let's take these 10 people over here and these 10 people over here, and we'll give these people the snake oil and these people water with, some food coloring in it, and we'll see how everyone feels afterwards. That's science. Confirming evidence is this. And I also use this example too, which is, you've seen these power bands or these magnet bracelets that have a magnet in it, and it says, oh, this is going to help to improve your balance. And we can do this in class because it's actually interesting what they've done. So what these people have done in order to create this is to take these bracelets and put them on people, okay, in the mall. And first they have you stand there and they put your arms out and stand on one foot, and then they push you. And then they put the bracelet on you and have you do the same thing, and they push you again. And the second time, oh my goodness, your balance is improved. Well, there's a couple of things that you can do. One, if you believe it's going to work, then you're like, oh my goodness, it improved. And right away, they got your money. It's a cheap plastic band with a cheap bracelet, and it probably costs them 50 cents max to manufacture, including the packaging. And they're selling these things for 30, 40, 50 bucks. And all they are is a cheap plastic band with a bracelet in it. So what they would really do is to, while you were standing, they would push you closer to your core, right? So one time they'd push you out on this side of your elbow, just barely, and on the other time, just barely inside. We're not very sensitive in that part of our body. And what would happen is you would feel more stable wearing the bracelet. So how is this not science? Well, it's confirming evidence. Basically, you want the scientific test, do the same thing we talked about with snake oil. 10 people in this group, 10 people in this group, give these people the snake oil, these people something else, and then see how they feel. And if the snake oil has alcohol in it, you give the other people alcohol too. And then you're like, oh, look, you just got them a little buzzed and they felt better. Larger trials, more people. And you do this and you see what actually works. Drug trials do the same thing. Why do you have to have placebos? You have to have placebos because if you have a placebo, you can actually see, right? So it's a drug that looks basically a sugar pill. And you're telling people, oh, this is going to make you feel better, or this is going to treat your illness. Well, if it does, it will. The placebo will have a positive effect because, again, if you believe it, it will have an effect, which is a very interesting area of study too. Same thing with anything like a magnet bracelet. If you believe that it's going to help you, it will. I mean, there was one point there was an NFL player who was wearing 2 on each wrist, right? Great advertising for these things, and people wearing them all the time. And then they fell out of favor. And I did this example in class one time, and I saw someone very, very slowly take their wrists off the desk and hide their hands under their desk because they were wearing one of these. If you fell for this, if you fall for any of these things, there's a lot of advertising that does this. It tries to manipulate you and to get your money. You're not alone. It happens all the time. Everybody, gets tricked into to this kind of thing, right? It's a matter of saying it's okay, right? Because people will then go the other way and they'll be like, no. Once someone gets tricked into something, they tend to defend it. And so you'll have someone who's generally rational defending something like the magnet bracelet, because if they don't, then it means they're admitting they got tricked. And we don't want to feel bad. So you see how insidious this kind of thing is. If you only pay attention to things that support your beliefs, you're in trouble. We need to rationally assess things that go against our beliefs. We have to accept that we could be wrong and that the things we believe could be being fed to us by a media that doesn't really care about our well-being. Well, I was at a conference a few years ago, and I observed this presentation that just drove me bonkers. So immediately it was cherry picking, right? It was a student did a study, and this was a research conference, and their advisor wasn't there, which was good for the advisor because, it was all I could do to not call the college and be like, how in the world did this happen? You just set back science, right? Anybody who was in that room, you hurt them. Because the person did the study believing that we can sense when someone is staring at us from behind, okay? Now, a lot of people have this belief. You ever feel someone staring at you? Sure, okay? But we can absolutely test this. How would we test this? If we actually have this, or if it's just an illusion? Well, oftentimes we might feel someone staring at us. What would be a rational explanation that doesn't involve being psychic? Okay? A rational explanation would be you caught something out of the corner of your eye. It didn't quite rise to the level of consciousness, but it hit your emotional centers, right, which have a much lower threshold, and you felt uncomfortable. So something led to your feeling uncomfortable, and you noticed that someone was looking at you. How about confirming evidence? You've felt that someone's looking at you many times, and most of the time you look and there's nobody there. But when there is, you're like, aha, I knew it. Also confirming evidence. So we can actually test this, and I've done this in class before, where you take 2 students, you take 3 students, okay? One of them is facing away from you, away, another person is facing that student. Okay, so you've got two chairs. One student is facing the wall. Another student is looking at that student from behind. A third student is looking at neither of them, looking maybe kind of set next to the student who is looking at the student, but not looking at that other person, because we don't want actually anyone looking at them unless it's controlled. That person's flipping a coin and signaling, look or don't look. So they'll point to the person, maybe one finger means look, two fingers means don't look. So the person who's being tested doesn't know if you're looking or not. And then the person is either looking at them or looking away. And the person running the study says, or who's flipping the coin says, are they looking? And the person says yes or no. So there's two conditions, either looking or not looking. And the person can respond with either yes, they're looking, or no, they're not looking. So you basically have how often are they right, how often are they wrong. If we're not psychic, you should be right half of the time. If we are psychic, you should be right more than half of the time. Well, we do this over and over again. And what we find is people can't tell. They can't tell if someone's looking or not. It's not a sense that we have. It's probably these other factors. But this student created the study based on the belief that they could tell. And so they had two conditions, but they weren't scientific. They were confirming evidence. Both conditions had someone stare at them. And in one condition, they had someone pay attention to being stared at. And the other, they said, think about something else. I don't even know how they came up with this because it doesn't make sense. And then they would be looked at for 4 seconds over a 30-second period. And the person doing the staring was told whenever they felt like it. 4 seconds out of 30 seconds is a large portion of time. And what they said was they could usually tell when someone was looking at them. And it was like, are you serious? There's no control group. There's no randomization. There's no repeated trials. Everyone got 2 trials. And so all they compared was, could they tell better when they were paying attention to it or when they weren't? I don't even know what to say to that. I asked some questions that were meant to not be too challenging, but just to figure out the design. And I had to leave because people in the room were saying things like, I can totally tell. Oh my goodness, I knew it. And it's just, yeah. So we have to understand how we do this, which means we have to be willing to collect evidence that we're wrong. And a study like this doesn't. It says we could be right. These are all areas that have been studied that have been shown to be pseudoscience, right? So you have things like astrology. Many people believe in their star sign somehow influences their future, their relationships. Crop circles have been shown to be nonsense. Ancient astronauts is this idea that these aliens built the pyramids and did all these things in human history. The evidence is super weak, right? There's nothing there. It's basically people jumping to conclusions based on incomplete data saying, well, we don't have evidence for this, therefore aliens. We mentioned handwriting analysis, the Bermuda Triangle, conversion therapy. That's the one where you try to change someone's sexual orientation. It's dangerous, it's false, it's unethical, and it's just bad. Polygraph testing, the Rorschach test, still used, often used by psychologists because when they're doing research or personality testing for the courts, they have to use 3 tests. So they'll throw the Rorschach in at the end because everybody knows what that is. It's got no validity except in severe thought disorders. Creationism, again, good evidence, right? You're looking at what makes a good theory and what doesn't. Parapsychology, I can read your mind. No, whenever it's been tested, it's been debunked, right? So it's the idea of confirming evidence, finding things that support our beliefs rather than saying, what does the evidence actually show? What does it show? Okay, what do we do? We can blame the media, but that doesn't get us anywhere. All media is not created equal. Some of it's good and rational, some of it's bad. But how do we know? Okay, so that doesn't help us that much. What we can do is say, what's the source of information? When we read a scientific study, when we see something reported in the media, we can go and we can find the research. And we can say, does this make sense? Who did this? Okay, and that's important too. If I've seen people quote things that end up being this kind of circular thing. Somebody said this, it was quoted, and then all of a sudden it becomes a fact. And you're like, well, where's the source? And it's like, this person's quoting themselves from like last year, and it was written up as if it was a thing. Well, here's another example. Are Oreos addictive? There was a story in the Huffington Post that said Oreos are more addictive than cocaine. Really? Like, I don't even know what to do with that. How do you write that headline and take yourself seriously? Okay, so what did they do? Oh, interesting. They reported on a Christian Science Monitor report. Generally a pretty good thing. And then we said, well, maybe there's other sources. Okay, here's a source from Forbes. Maybe you're more likely to believe Forbes. Research shows that Oreos are just as addictive as drugs. Research shows that cocaine and heroin are less addictive than Oreos. What? Where? Where does it say that? So I traced it back. I said, okay, the original report was in the Christian Science Monitor, generally a pretty decent, report for things. Oreos addictive? Rats treat Oreos like cocaine, study says. Okay, hold on. The other two said Oreos are more addictive than cocaine. And more addictive than cocaine and heroin. But they're quoting this source that says rats treat Oreos like cocaine. Well, that's not the same thing. So then we said, let's look at the actual study. What did they report? It was never published, but it got picked up by the media because it was a press release and it was sexy. So here is the original report, and what they said was, is just as addictive, at least for lab rats, so bad, suggests Oreos can be compared to drugs of abuse. Well, that's different than just as addictive as cocaine. So we're getting a hyped up interpretation of something. So let's look at what they actually did. There's a famous study where you take cocaine and you put it, I don't know who writes these studies and gets these things approved, but there's plenty of studies where somebody managed to get a hold of some cocaine and gave it to rats. Yeah, rats. So they take the cocaine and they take the rats and they put the rats into a little box, and there's two rooms in the box. One has cocaine and the other one has, I don't know, crackers. And then where did the rat go? Well, the rat goes to where the cocaine is. We're not surprised. And then when the cocaine and when there's nothing in there, the rat goes back looking for the cocaine. They don't go to the other room. Are you surprised? No. So what did they do? They took the Oreos. Did they use cocaine in the study? No, not at all. They took Oreos, stuck them in one room, put crackers in the other. And where's the rat going to go? Well, Oreos are delicious. Nobody knows what's in that white stuff. It's some kind of witchcraft magic. It's not food, but it's amazing. So the rats go, they eat the Oreos, and then later on they put the rats back in, and what do the rats go look for? They look for the crackers or the Oreos. They go look for Oreos. They didn't compare the Oreos to cocaine. All they did was mimic the study and show that, oh yes, rats like cocaine. Rats also like Oreos. That was it. That was it. And you end up with these headlines of Oreos are more addictive than cocaine. Baffling. Baffling. But what does it tell us? What's the lesson? You see the headline, look for the study. Sometimes it's this obvious. And this was in the media for weeks. And anybody who had common sense read it and was like, no, absolutely not. So when we're looking at these studies, we also need another concept, which is called randomization, right? Which is kind of like a couple ways of doing that: random sample and random assignment. A random sample, a good survey, right? Why are we, we're getting these weird polls, for instance, polls that are way off. Well, one of the explanations is that only some people are willing to respond to polls. And so we're getting a very odd sample, right? In a true random sample, you select a certain portion of the population randomly, and you have to get those people to respond. right? You have to get the majority of those people to respond, or you're not going to get a good sample. With a random assignment, you assign volunteers to a condition, so each condition is equally likely. So if we're doing a study, you come in, I flip a coin, and I either put you in condition A or condition B. Well, there's different types of studies, and these are observations, surveys, and experiments. So when we look at each of these, we look at the observation, we say there's two main ways of doing this. One is a naturalistic observation. A clinical case study is an observation. An ethnography, where you go and you study people and look at their culture. That's an observation. Hypothesis testing is saying, I believe I'm going to see this difference. One study looked at, college students and said, who's more likely to walk in a group, males or females? You can go out there and you observe it. But you say, I think that this group is going to do this. You also have to have a hypothesis of change. The next one is a survey. And there are scientific surveys that involve, polling, group research. You have to have careful design, hypothesis testing, careful selection of subjects and randomness to it, and a planned data analysis, rather than just asking people questions and seeing what happens. Now, in a survey, we're often looking for something called a relationship. So many things are related. For instance, relationships, wealth and charity. Who gives a bigger proportion of their income to charity? Wealthy people or poor people? Well, surprisingly, the answer is poor people give a larger proportion. Wealthy people may feel like they're giving more, but it affects them less. Time studying and grades. This is what we think. The more time you study, the more your grades will improve. And then there's things that aren't related. For instance, shoe size and hours of sleep, IQ, and the number of pockets, in your clothes. These things are not related. And we're looking here at correlation, negative, 0, and positive. A correlation can be negative. It can mean as one goes up, the other goes down, right? The more time you spend partying, the poorer your grades. As one variable goes up, the other goes down. Or it can be the more time you study, the better your grades. Or you could have 0 correlation, which would be like shoe size and the hours of sleep that you get. In adults, correlation describes a relationship. You collect information and describe it. A classic example is ice cream and drowning. For instance, this is in every stats class. There is a correlation, a positive relationship between ice cream consumption and the number of drownings that happen. This is not surprising. But when you ask people to explain it, they often say something like, well, when people eat a lot of ice cream, they get full, and then they swim, and they're digesting, and they drown. But that's not it. The reason that these things are correlated is a third variable, right? The third variable problem, which is it's summer. When it's summer, more people swim, and people consume more ice cream. Ice cream doesn't cause drowning. But sometimes when we see a positive relationship or a negative relationship, we try to say one thing's causing another. Cause requires experimental methodology with manipulation. The illusory correlation is we see correlations where they don't exist. For instance, the full moon, right? The full moon effect. When there's a full moon, do people act crazy? We believe that they do. And the people who buy into it the most are emergency room nurses and doctors and police, because they see the full moon and they're like, oh my goodness, it's going to be this way. Confirming evidence, right? When there's a full moon and you're busy, you're like, I knew it. When there's a full moon and you're not, you just ignore it, right? So we pay attention to things that support the beliefs we already have. So we're looking at the experiment, right? And what makes the experiment special? Well, an experiment is designed around a manipulation. A group gets a treatment or not. It can be used for program analysis. Groups are carefully created. You say, okay, I want to do a new math program in high schools. So let's see if this works. You don't just scrap the old one and put the new one in. You take half of the kids, put them in the new program, half of the kids put them in the old program, and see what are the outcomes. That's the manipulation. And that's called an independent variable. Which group do you get? the new group, the new method or the old method, the experimental group or the control group. And then you measure the outcome. The IV is the independent variable. The DV is the dependent variable. The words independent and dependent are a little odd because they don't really connect. So we just think of it as, that's what they mean. That's what IV and DV mean. But the IV is what's manipulated, which is what group someone's in. And the DV is the outcome. All right. How can we best describe the theory? For instance, is it a hypothesis, explanation, prediction, or fact? And the answer is, it is a explanation. Now, remember, sometimes theories are as close to facts as they can be, right? If gravity, we know about gravity. If I were to drop this pen, what's going to happen? It's going to fall, right? That's our prediction. Well, we've seen a lot of observations. But there are many theories that have so much support they're accepted as fact, and then there's bad research, right? For instance, the vaccine and autism myth. People still believe the vaccines cause autism. This has been widely debunked for years. And yet, once people believe a certain thing, it's hard to convince them they're wrong, right? Because in the same way that once someone's wearing a magnetic bracelet that they've spent money on, they don't want to feel like they've been ripped off. And what happened was, I think, early on, there was this one really bad study by a researcher who ended up getting their credentials pulled. This person has basically been kicked out of science for doing bad research and causing, well, spikes in preventable childhood illnesses. Celebrities wanting to believe that their autistic kid was not a random act, but that they had someone to blame, glommed onto this and created more tragedy. And children die because parents don't vaccinate because they still get wrapped up in this myth. When you go back and you look at the actual evidence, this is what you find. You find it was one bad study that wasn't supported. But since then, there have been so many opinions, so many people who want to believe this and do bad research full of confirming evidence that's debunked by any reasonable scientist. But they want to believe. And so they end up believing something that's not true. And the outcome is tragedy. And children die of or are permanently injured by preventable illnesses. One bad paper by somebody who went in there with a bad sample and wanted to believe something, and people wanted to believe it was true. This type of study includes a manipulation, observation, theory, survey, or experiment. And the answer is experiment. This type of study involves asking questions, same answers, and it is, well, we're looking for survey. But you can ask questions in any study, but solely questions would be this. So we talked about the scientific method, right? And we observe a problem in the world, and then we make a prediction about what will happen, and we create a study and collect data. There's a few terms we want to understand because they're heavily involved in research, and these are our statistics. So when we have data, we have to do an analysis, and our analysis has built in the understanding that we could be wrong. And there's some points that we need to understand. For instance, the average. The mean is another word for the average. The median is the midpoint. And oftentimes, these are both similar. But when they disagree, they tell us something about the sample. If you were to take 100, let's say, prices of houses in your town, the one in the middle is a better explanation of the market than the average, because it'll be weighted very heavily by what we call outliers. Depending on the sample, you may want the average or the midpoint. Standard deviation and range give us the same kind of idea, where you have measures of variability, where depending on the sample, they tell you how much do we expect spread. We calculate a midpoint or a mean, and we get an idea of where we expect people to be. The standard deviation and range, these measures of variability, tell us how clustered around that midpoint do we expect people to be? And then we look at statistical significance, which is, did we find something? All right. So we'll take a pause here, and the next section will be on ethics. Thank you.